Okay, now we're going to look at a confidence interval for a population or for population proportions. And this is chapter 8.3 in your OpenStax book. So basically, we're going to be going back to Z sub alpha over 2. The formula is, if you want to calculate by hand, it's a p hat. Your book did mention that some books will use, instead of p hat, they'll use a p prime. I will use p hat. So p hat plus or minus your margin of error. And again, your book uses this error bound for proportion. So EBP, just like we did on the EBM. I won't be using that. I'll just use margin of error. And the margin of error is Z sub alpha over 2. The square root of P times Q over N. We talked about what P and Q are, but we're going to use technology to calculate this for us, so we won't worry about that. Let's go and see what we're given. So we're given a sample size of 400 of adults aged 18 to 30. 104, so X is equal to 104. Still live with their parents. Okay. Based on this, construct the 90% confidence interval alpha, and this is just habit for me. Alpha is equal to 0.10 or 0.1 or 0.10, so your confidence interval is 90%. Okay. And if I haven't saved it before, our common confidence intervals when we're using Z sub, either the Z sub alpha over 2, the common confidence intervals are 90, 95, and 99. Okay. If you had to calculate by hand. If I haven't said this before, if you do a 90% confidence interval, the width of your confidence interval is smaller than a 95% because you're more confident. If you're 95% confident, then the width of that interval confidence interval gets larger. And then if you're even 99%, it gets even larger than that. So I always question, well, why not always do 99%? And I think they may do that with testing of pharmaceuticals to combat certain diseases or things that are health issues or whatever. But mostly for, I think the example I was talking about was the miles per gallon for cars, new car. They're going to get that tightest confidence interval that they can legally, and they'll use the 90% one because it is less lax, for lack of a better word. You're only 9% confident that the true mean, or in this case, the true proportion is going to fall in there. So, just wanted to point that out. The higher your confidence level is in terms of how confident you are, the wider your confidence interval will be, which is going to have maybe some extreme values in it. So let's go here. So, true population of adults, okay, that live with their parents around the 4 decimal places. Alrighty. So, let's see what we're given here. Now, we are estimating a population proportion. This is the p hat is your sample proportion. Okay. P hat is your sample proportion, which is going to estimate your population proportion, which is what is going to be in your interval, is going to be simply equal to P. So, not a P hat, so that's going to be there. So, let's go ahead and use StatDisk. Let me see if I can slide this over. Oh, here, yeah, I've got it here. No. So, we're going to go to Analysis, Confidence Interval, Proportion, one sample. Okay, it's going to ask for your confidence level, which is going to be 0.90. Your sample size in this case is 400, And your number of successes is your X value. What was X? Because you're asking if you still live with parents, which is 104. Okay, 104. Evaluate. So notice that our confidence interval, don't worry about the Wilson score one. We want this one up here using normal approximation, is 0.22393 is less than P is less than 0.29607. Let's round those to 4 decimal places. 0.2239 is less than P. 0.2961. So let's go ahead and put those in there. 0.2239. 0.2961. Submit. Let me know if you have any questions. Thanks.